Good morning, 6th graders. Today's lesson is 11.2, where we will be working on adding integers. So up until this point, you've seen some negative numbers and you've dealt with them a little bit, but we've never added them together. So that's what this lesson is going to be about. And for your learning target, it's I can add integers with the same signs and different signs. So there will be both examples today that you'll learn about. For our key idea, this is the first set of problems that you'll see is just when our integers have the same sign. Okay, adding integers with the same sign. So that either means that they're both positive or they're both negative. It says to do that, add the absolute values of the integers and then use the common sign. So in this case, 2 plus 5, well, the absolute value of 2 and 5 is 2 and 5. And then the common sign is a positive, so you're going to end up with a positive answer. Okay? And same with the negative, where what is the absolute value of negative 2? The absolute value of negative 2 is 2. The absolute value of negative 5 is 5. So 2 plus 5 is 7. And then use the common sign. Well, their common sign was a negative. So that's how they arrived at negative 7. I'll show you a couple different methods today to do this. So let's look at the first example. It says find negative 2 plus 4 plus negative 4 and use a number line to check your answer. Okay, so let's make a number line here. Sorry, it's not the straightest. I need negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, negative 6, and I can make that bigger if I needed to. All right, and what I'm going to do is I'm going to start at 0 and go to my first number, which is at negative 2. And there's this little method that I like to use called start, face, do. And it works really well when you have like a physical number line with you. So you start at negative 2, that's the number we're starting at. We face the sign, so we face the addition way, which if we were adding would be going right. So I would be looking this way, and then do, so I'm adding, and then do, what's my next number? My next number is negative 4. So I need to take 4 steps, but I need to take 4 steps in the backward direction since it's negative. So 1, 2, 3, 4 backwards puts me at negative 6. So in this case, negative 2 plus negative 4 would equal negative 6. Now that follows the same rule we just had up here. What's the absolute value of negative 2? Well, the absolute value of negative 2 is 2, plus the absolute value of negative 4 is 4. So 2 plus 4 gives me 6. And then use their common sign. Well, their common sign is a negative. So negative 6 would be my answer. There's another way to think about this, and I like to use these oftentimes. They're called integer counters. And you can just use like little positives and negatives. You can use different colored blocks. Legos are good, anything like that. But what this is saying is that you have 2 negatives. There's my 2 negatives. And what I'm doing is I'm adding 4 more negatives to that. 1, 2, 3, 4. I've got 2 negatives, and if I added 6 negatives, 4 negatives, I'd be at 6 negatives. Think about it as Legos. Here's 1, 2 Legos plus 4 Legos, and if I add them all together, I'd have 6 Legos. But since they're negative, it's just I have negative 6 of them. Okay, so integer counters are really helpful when we have different signs, which we'll get to next section. But it works with positives too. Say you had, I'm going to use a different color. Say we had 3 positives, and I added to that 1 positive. 3 positives plus 1 positive would give me 4. And since they're positive, my answer remains positive. Okay. So lots of different ways to think about these types of problems. Hopefully that one of them resonated with you. If you have questions, let me know, but pause the video now to try the on your own. Okay, for 1, they're both positive, so my answer will remain positive when I'm adding them. So 7 plus 13 gives me 20. Keep the positive. Absolute value of negative 8 is 8. Absolute value of negative 5 is 5. So 8 plus 5 would give me 13. And keep their common sign, which is a negative. Same here. Absolute value of negative 20 is 20. Absolute value of negative 15 is 15. 20 plus 15 would give me 35. And for the sign, I would keep the common sign, which is a negative. Right? So hopefully those went all right for you. Quick vocab here, and I think this might seem like some common sense, but it's really good to just think about it. So it says 2 numbers that are the same distance from 0, but on opposite sides of 0 are called opposites. So if I'm thinking about a number line, and I've got 0 in the middle, and I've got 1, 2 here, and I've got negative 1, negative 2 here. If I were to pick negative 2 and ask you, how far from 0 is that? Well, it's 1, 2 away from 0. And if I pick 2, that is also 1, 2 away from 0. So that's why we say 2 and negative 2 are opposites, because they're both the same distance from 0. For example, negative 3 and 3 are opposites. All right, they're the same distance from 0 on a number line, but one is positive and one is negative. Okay. That might seem a little like common sense, but you'll see how we use it here coming up. So now it gets a little bit trickier, because now we're adding integers with different signs. So one of our numbers is positive and one of our numbers is negative. Okay. What are we going to do in this situation? To me, it's kind of like in a game of football. You say one play, the running back gains 8 yards. So he had a good rush for 8 yards ahead. And then on the next play, the defense gets a little bit smarter and they send a blitz. And now this time the running back loses 2 yards. So it's like we're going positive 8 yards. But on the next play, instead of going positive, he loses 2 yards. What would the net of that be? Okay, so that's kind of going to be how these problems are going to work, essentially. That's just a simplified version. So it says to subtract or to add integers with different signs, subtract the lesser absolute value from the greater absolute value. Then use the sign of the integer with the greater absolute value. Interesting. So for example, we have 8 plus negative 10. Well, subtract the lesser absolute value. 8 has a less absolute value than 10 because the absolute value of this is 10. So if you take 10 minus 8, you'd arrive at 2. And use the sign of the integer with the greater absolute value, which was this one. So we're going to use the negative sign, negative 2. Same here. 13 is the lesser absolute value, so you'd subtract that from 17. So 17 minus 13 would give you 4. and then take the sign of the number with the greater absolute value. Well, 17 has a greater absolute value, and it's positive, so our answer gets a positive to it. That might sound rather confusing right now, but we'll get a bunch of practice with it. And then they also stick in this additive inverse property. It says the sum of an integer and its additive inverse or opposite is 0. Anytime you hear this fancy vocab word, additive inverse, that just means opposite. So it's saying when you add an integer and its opposite, so when you add, like in the example before, -3 plus 3, you always get 0. Always, always, always. 6 plus -6, 0. -25 plus 25, 0. These type of problems remind me of repaying a debt. So say, for example, I owe you $20. I had to borrow $20 from you. Well, now my how much is in my bank? Well, I actually have -$20 because I still owe you $20. So once I make that $20, I can pay you back that positive $20 that I borrowed from you. Now I don't owe you any money. Yeah, that's kind of the what I think of when I think of the additive inverse property. Basically, when you add opposites, you get 0. And it's really easy to show that with integer counters because, say for example, let's use just 2. Say I had 2 plus -2. Well, I can represent 2 with 2 positives plus I'm adding to that 2 negatives. Well, +1 and -1 cancel out, right? -1 plus 1 is 0, and this positive and that negative cancel. I'm left with nothing. Okay. So hopefully I haven't confused you with all that blabbering, but let's go to a few of the examples here. It says find 5 plus -10. So which of these has a greater absolute value? So the absolute value of 5 is 5, and the absolute value of -10 is 10. So in the hints that they gave us up here, they said subtract the lesser absolute value, so the lesser of these is 5, from the greater absolute value. So the greater absolute value is 10. So I'm kind of forgetting about my signs for a moment. So I'm just going to say, okay, 10 minus 5 gives me 5. And then use the sign of the integer with the greater absolute value. All right, the greater absolute value is 10, and its sign was negative. So my answer is -5. Now, that makes sense because if I'm looking here, do I have more negatives or positives? Well, I have 10 negatives and I only have 5 positives. So I should end up with more negatives in the end. If I were to use integer counters, it would look like this. I'd have 1, 2, 3, 4, 5 positives, and I'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 negatives. My positives, 1 positive and 1 negative, would cancel, right? +1 minus 1 is 0, and I'm left with 1, 2, 3, 4, 5 negatives. Exactly what I got in letter A. All right, let's try letter B. -3 plus 7. All right, this is the smaller of the two absolute values, so I would do 7 minus 3, which would give me 4. And then I'm thinking to myself, which of these has the greater absolute value? Well, 7 does, and it's positive, so my answer will stay +4. If you want to think about it using integer counters, you have 3 negatives, 1, 2, 3, and you have 7 positives, 1, 2, 3, 4, 5, 6, 7. -1, +1 will cancel, and I have 1, 2, 3, 4 positives left. And lastly, for letter C, I have an example that I rambled on about the additive inverse, or opposites. And anytime you add opposites, you end up at 0. All right, in example 3, we'll talk about what about a situation where you don't just have two numbers, but you have more than two numbers? How does that work? All right. It says the list shows 4 bank account transactions in July. Find the change, C, in the account balance. Find the sum of the 4 transactions. All right, so if I'm looking at this, I've got a withdrawal, which means I take money out, and a deposit, which means I put money in. Okay, then I put $75 in the bank again, and then I took out $50. Okay. There are a couple different ways to do this, but before I just start adding one by the next, I'm going to look at my numbers. If you look closely, you see that we have an example of the additive inverse. We have a deposit of $50 and a withdrawal of $50. So these two are opposites. If you add those, you'd end up with 0. Okay, this deposit and this withdrawal essentially cancel each other out, which is really nice and handy. Now, all we have to do is take our negative 40 and add 75. Negative 40 plus 75. Okay, they have different signs, so I'm going to have to subtract them and subtract the lesser absolute value from the greater. So this would be an absolute value of 40. This would be an absolute value of 75. So when I subtract them, I'm going to take 75 minus 40, which would give me 35. And then which of these has the greater absolute value? Well, 75 does, and it's positive. So I'm going to leave my answer positive. So the change in the account balance increased by $35. Since our number is positive, that means our July transactions increased by $35. Okay. Please pause the video now for the last on your own section. For number 4, you should have arrived at negative 2 plus 11. Well, that will give you 9. Have a lot more positives than negatives, so your answer should be positive. Number 5, 9 plus negative 10 would be negative 1. And then number 6, these are opposites, so they would be 0 when you add it together. And then it says in example 3, the deposit amounts are 30 and 40. So this is now 30, and this is now 40. Find the change. Well, so we have negative 40, 30, 75, 40. It kind of works out the same here because this negative 40 and this positive 40 cancel. And then all we have to do is look at our... Did I do that right? Let me try that again. The deposit amounts are 30 and, here I put this in wrong, 30 and 40. This one would stay at negative 50. All right, that looks better because now this negative 40 and this positive 40 would cancel. And then I'd be left with a deposit of 30 and a withdrawal of negative 50. Okay, now we have more negative than we do positive. So if I did 50 minus 30, I'd arrive at 20. And since 50 has a greater absolute value, it would be negative. All right. So hopefully going through a bunch of those problems gave you at least one or two ways to add integers, whether that be with the same sign or different sign. If you have more questions, please let me know. That does it for adding integers and 11.2. I will see you guys next time.